to do all this.
Well, we're going to find out here. So everybody, hey, welcome to the.
That off real quick.
Oh, there we go. Okay, there we go. Slight false start there. Hey, welcome everybody to the Great Debate community page. This is Steve. I'm going to be doing a little presentation, a little hangout on order of operations. It's nothing going to be extravagant by any stretch of the imagination. Somebody had asked me, since we're doing some of this math stuff, wouldn't it be better to kind of have a hangout on just some of the basics? Very, very simple maths. And order of operations is about as basic as you can get as far as how to do problem solving. So I have this little presentation. It's just basically simple, a little bit harder and a little bit harder to do order of operations to make sure that everybody's on the same page, that when they see a problem, they know how to do the steps in order to arrive at the correct answer, whether it be a problem that we're solving or an expression that we're evaluating. Order of operations is critical. Anybody who's ever taking math needs to get order of operations down cold to the point where they can literally almost do them in their head. So what we're going to be doing is I have David here. I'm going to be showing him some problems, and we're going to be working through these problems to see if we can get the right answers. This is basic level. Again, this is not complicated. This is probably third, fourth grade math, maybe fifth. I don't know, somewhere in that ballpark. It's elementary arithmetic. So it's not high level. Should everybody be able to follow along really easy? Most of you probably already know this, but for the people that don't, it's good review. So let me present here. And okay, present. Can you see my page, Dave?
PEMDAS, yes.
Awesome, PEMDAS. Yes, a lot of you guys remember the acronym PEMDAS. PEMDAS is parentheses, exponentiation or exponents, multiplication, division, addition, subtraction. Some people may have learned it as, please excuse my dear Aunt Sally, as the mnemonic to memorize that acronym. However, it doesn't really matter how you memorize it, and it's not really a great way to memorize it. However, it works for practical purposes, but it does lead to some confusion. The confusion is these are not exactly the order that you do a problem. You do not do them as multiplication, then division, nor do you do it addition, then subtraction. Where you do it is in the order they appear in reading left to right, with the exception of the first two, P and E. Parentheses or parenthetical groups are always done first. So you always do the inside of the parentheses, then you do the exponentiation, and then you do multiplication and or division, depending on the order they appear, and then addition and subtraction. So the way it kind of more looks is like this: PE, MD, and ANS. So yeah, you kind of have to memorize PEMDAS as this, because people get focused on the acronym and they say, oh, you always do multiplication first. Well, no, you don't. Again, depending on the order that they appear, reading it from left to right. Other places overseas might have memorized it differently in their schools. They might have memorized as BIDMOS, BODMOS, BEDMOS, PPMDAS, or MDAS. And these are just acronyms that mean the same thing. Here we have brackets instead of parentheses. Here we have indices, which is just another way to say exponents. Here we have order, which is another way to say exponents. And here we have exponents. So it's just basically brackets, exponents, division, multiplication, addition, subtraction. Now remember, because PEMDAS, the M and D, are read left to right, this is the same as saying BEMDAS. This is the same as saying BODMSA. You can reverse the A and the S and the M and D anytime you need to, as long as you're reading it left to right. So you do the multiplication first if the operator is shown first, or you do division, depending on the reading of the expression or the equation. And again, the difference between an equation and an expression is an expression does not have an equal sign, an equation does. So far, are you with me, Dave?
With you.
Okay, so which of these, in the acronym PEMDAS, which two are always done in the order first? You just get them out of the way first. Which ones are those?
Parentheses and exponents.
Parentheses and exponents. All right, so let's try to evaluate the first expression here. 2 plus 2 times 4. Now, this would be something that most people could probably do in their head. However, you'd be surprised how many people would get something like this wrong. Not Not dogging on them. Again, people forget the order of operations. They say they learned them incorrectly. They say the teacher sucked. I get that. But this should be something that if you need to do mathematics, everybody should be able to do in their head just instantly by looking at it. So let's take a shot in the dark. Can you solve this? Well, excuse me, can you evaluate this just by looking at it in your head?
Yeah, I get 10.
All right, 10. Let's see if that's right. The other answer that's out there that people will say, what do you think the wrong answer, or that is the correct answer? We're going to show why, but what do you think if somebody does it incorrect, what they're going to get?
I think they probably get 16.
Right, and why do they get that wrong answer?
Because they first add the 2 and the 2.
Correct. Right. So they're doing it out of order of operations. Oh, let me give you a, just in case people show up. God dang it, I didn't mean to do that. Let me give you control so people can be shown as they appear in here. Because I won't be paying attention to the inside chat, if you don't mind.
I'm back.
Yeah. The link to join is in the Great Debate community. Anybody can come in. But like I said, I'll be looking at the video here, or my presentation, so I won't be able to show people. So anyways, let's find out why that's correct.
May I interrupt before you go too far, Steve? Because I was not broadcast when you were at that point. What in the line of different acronyms for the same crap? Mm-hmm. What's the second P in PP mean? PPMEAS.
Power.
Power. Okay.
Yeah. Good question. Yeah.
That's the one you didn't cover.
I did not say that. I forgot. Correct. Power, exponents, order, and indices all mean the same thing. It just depends on where you're learning it over in the European countries, Canada, Mexico.
Yeah.
There's a lot of things that simple. Matter of fact, the next presentation I do is going to be on symbology, and showing people different types of symbols, what they mean in math. Because, for example, like we use for a decimal place, we use the period, right? Yeah. Well, what do you think they use in Mexico?
The comma.
The comma, right. So it can get confusing. So I kind of want to have a little hangout on symbols, what they mean when you see them. And then somebody had wanted me to do a presentation on linear equations and then matrices, which is fine. But I didn't want to do the matrices first because you can't really jump into matrix without learning linear equations. I don't think it would make sense to do so because obviously they're intricately entwined with each other. So, yeah, so I'll do the matrix ones afterwards. But we're going to do this a little more step by step because we jumped into it with Calc 2 stuff, right? Which are fun. I want to do more like that, but I want to have some basic educational ones as well. So, and again, let me clarify to anybody who doesn't know who I am or who the Great Debate community is. I am not a mathematician. I am not an expert. I am a layperson, but I've had some.
What happened? Hello? Dave, you there?
Right.
Yeah, I'm here.
Okay, good, because Steve just stopped presenting his PowerPoint.
Oh, am I not presenting?
Yeah. As soon as I said calculator, it all went dead.
Okay, one sec. Let me present again.
And remember, people, this is not a debate because Steve is using a PowerPoint, and you're not permitted to use PowerPoints in a debate.
According to
Ronnie.
Okay, so yeah, just according to him. Anybody else, it's completely fine.
So we are having discussion, not a debate. Let's get that clear now.
Well, this is math. You don't really. There are some things you can debate in math. Don't get me wrong. Some paradoxes and stuff like that. But this is not debatable stuff. Except the very end. The very end of this presentation, I'll show you something which is non-debatable, but people still try to debate it, and I'll show you why that they're wrong. Okay. But anyways, can you guys see the presentation now?
No.
Really? Nope. I'm screen sharing. Okay, let's try this one more time. Google is really kind of fickle with this, isn't it? Sometimes. Okay, share.
I think it's going to start soon.
I'm screen sharing.
No.
Why is it?
Yeah. It says you're not presenting now.
Okay.
I'm presenting, but it's not showing my screen.
All right, Steve, you might have to F5.
See, why'd you have to make me stop presenting?
I did.
Oh, you know what? Let me do it this way. I'll have to do it this way. Let me now let's see here. You guys are not seeing my screen at all, are you?
No.
One more time. Let me just do an application window, see if that works.
Are you on OBS?
No, I'm just using the internal Hangout. No, see, that's not showing anything. Do you think I should go F5?
Let me just check YouTube for a second.
Yeah, it's not showing on YouTube either.
Yeah, let me F5.
Yeah, and I'm not showing either as part of the group.
There we go.
There it
now,
is.
Now we see it.
F5 just solves everything, doesn't it?
Yes, F5 for the win.
Yeah. All right, so we end up with 2 plus 8, and then as you do the addition here, 2 plus 8 equals 10. Very simple. So if you didn't get 10, you might need a little practice, but everybody should be able to at least do that in their head. Now, the next one's going to be a little bit more difficult. Again, these are not hard. 5th grade math here, 3rd grade maybe. But it looks a little more complicated. And I'm actually using what's called, I got some feedback. I'm going to be using what's called an obelisk, okay? An obelisk. An obelisk is this symbol right here. It means division. You see it in elementary maths. You don't see it in higher maths. There are some reasons for that. Matter of fact, if you really want to get technical, it is forbidden by the industry standard, the industry standards of symbology and symbols. They forbid this symbol to be used in higher maths. You don't see this in any proofs.
Is there a reason for it?
Yeah, because there's some ambiguity with the symbol.
Yeah, I was going to say it's kind of questionable whether it covers, like in this case, whether it's over the 3 only or the 3 and the 5 as added together. It's a grouping symbol.
This originally, original symbol, because the typesetting for it literally meant, here you have this bar here, which is a funiculum, it's called, was really meant to separate the top and the bottom because of typesetting reasons. That's it. But in modern math, this actually means it's on a calculator, and it just means division, which is the same as the slash or what's called the solidus, which is just the diagonal. You've all seen that, right? So that's why it's confusing, but I'm using this for a reason. But in this particular, because you see it often like this in elementary school, they start off with the obelisk. So that's why I'm using it for here. Okay, so let's evaluate this first. The first thing we want to do is obviously parentheses. So what are we going to evaluate the inside of the parentheses as?
Oh, that would be 7.
Yeah.
Okay. So once we've evaluated the inside of the parentheses, P is done. There are people out there who say, well, no, you need to get rid of these brackets here. Okay, these parentheses. No, that is not what the P means in PEMDAS. The P just means that you do everything internal to the brackets first. It has nothing to do with the outside. Now, if you remember from the presentation I did yesterday, anytime you see a number next to a bracket like this, that means multiplication. Okay, it's called implicit multiplication by implicit multiplication by juxtaposition. It's fancy speak for just saying multiply. Okay, so if that means multiply, let's go to the next one. There's no exponents. Would you agree? Sure.
Yeah.
All right. So we're going to go to multiplication and division. Here is where you multiply. Now here's where it gets a little bit more confusing. As David pointed out, is this saying 2 minus 42 is over 3 plus 5? Well, if you're looking at this from like 150 years ago, that may have been what it meant. If you make a look at somebody, I think Euler may have done it that way a few times, or some other people. Yeah, that there is some instances of that because of typographical reasoning, not mathematical. So in modern math, we're going to be treating this obelisk as division, like the calculator. In this particular case, and again, you don't need brackets for these order of operations. Brackets are only to change the order of operations. Because if you notice here, my brackets change the fact that I'm doing a addition operation prior to anything else. So what these grouping things do is change what would be normally the order of operations. So 42 divided by 3 is
14.
14. So the next step is going to do the addition and subtraction. Now, this is again where people get confused, right? Because they want to do the addition here, right, before they do the subtraction, in which case they're going to get 14 plus 5 equals 19, and 2 minus 19 is going to be minus 17. That's not the correct answer. So what is the correct way to do this, David?
Well, it's just in order. You just do 2, and then you take a negative 14.
Leaving you?
Negative 12 plus 5 is negative 7.
There you go. So the correct answer to this is negative 7. Okay. Let's go to the next one. The next one's, again, going to be a little bit more difficult. Okay.
Woohoo.
I pull these out of my butthole, by the way. I just let you know these are just completely out of. I just made this up, and then I'll show you how I check it. But anyways,
North Korea is watching. These are not nuclear secrets.
Yeah, this is not like I learned in nuke school, which was confidential and classified information. This is actually, you know.
Yeah, they use completely different math and different symbols there.
You can learn this anyway. So.
Nuclear decay rates not included.
I'm going to be doing I'm probably going to be doing a presentation eventually on nuclear decay rates, and I also want to do another one, or I did one on work of a function. For example, Carnot efficiency. I was going to want to be able to explain to people if they're interested how you have a 4-step process in a work process where you have a change in pressure, change in volume, and the integral of that is equal to the work of the product of the pressure and volume. But that's complicated stuff, and in order to get to that, we have to actually learn more about integrations. But eventually, that's kind of what I want to do with some physics stuff, because that's what I went to school for, was learn how to do thermodynamics. But it's been a lot of years, and I really would like to get back into that a little bit. Oh, Scuba Steve just said, how about fluid dynamics? Yeah, in the live chat. Yes, Scuba Steve. See, he knows that was a nuke. So yeah, he knows I had to take fluid dynamics. But I'll get into like things eventually, like the ideal gas law. Was it PV equals nRT? And again, I'm going back many years here. Boyle's law, Charles' law, how they relate, or Avogadro's law, and how they relate to ideal gas law. Cool stuff, but that's for another hangout. Okay, so let's get to this one. What I like to do on something like this, the first thing we have to look at is the parentheses here, the parenthetical group. Now we see 2 operators here for the division and multiplication. Obviously, there's no exponents, so we can skip the exponentiation. We have to do the division first, but 1/2 is reduced, right? You know, it's a reduced thing. But I still like to do it if I saw something like this and get to 0.5, because then I know that I'm not going to get confused by, is it 3/1 divided by 2 times 12? No, I know that this term is a separate term. So it's 3 minus the term 1/2 times the term 12. So by restating it this way, right, I'm avoiding that confusion. Does that make sense, Dave, to do it that way?
Yeah, it does, because a lot of people don't realize when you see that, that's actually a fraction. If it was actually meant to be 3 minus 1 all over 2, you would see an extra set of parentheses around the 3 minus 1.
Correct. So it is 1 divided by 2, which is the same as 1/2. So this is a fraction. This is an individual term. You remember in algebra, if you guys remember back in the algebra days, terms are separated by addition and subtraction, right? So or an operator. But anyway, so here I'll do this first. What is it? The next thing is a multiplication, right? So I'll take 1/2 of 12, correct? Which is 6. Okay, now I'm doing A and S, which is 3 minus 6. So I'm left with -3. Now the parenthetical has worked. Now we go back to the PEMDAS again. We go back to the P. No, I've done all the other brackets. There's no other brackets to do. There's no exponents. So the next thing is going to be back to M and D. In which case, here I have division first. This is called a solidus, or slash. I want to do that operator first, and that's called by the way, it's called a partial binary operator. The multiplication sign here is a binary operator. This is stuff you learn in more advanced stuff. But you think, can anybody tell me why the division is not called a true binary operator? It's called, well, it's a binary operator. It's a specific type. It's called a partial. Can you think of any reason why it would only be a partial binary operator? And binary just means it operates on 2 things, right? A unitary operator would be something like minus, because it's only operating on 1 thing. But a binary operator has 2 inputs, or 2 operands. So why do you think division is partial? What is it you can never divide by?
Well, you can't divide by
0.
There you go. So there's an exception, right? That's division by 0. You cannot do in the real numbers. There are ways to do it in higher maths. When you're working on the complex numbers, it's called the North Pole, the Riemann sphere, if I remember correctly. But we don't want to divide by 0. So that's why it's a partial binary operator. So we do that multiplication with division, and then we do the next one, which is multiplication. So we end up at minus 33, right? And then we just do the next multiplication, which is here, which is going to be 1 times 8, which is 8. And then we do our addition and subtraction. So I have a negative 33 minus 15, which is going to give me negative 48 plus 8 equals 40. Now, the way I like to check this would be something like this, and I'm going to show you on the screen now. Is a program called Wolfram Alfram. Great little program. Okay. I put each step into this top part. Can you guys see this?
Yeah.
Yes.
It evaluates as true. That's a good thing. That means we got it right. So I entered this exactly as we did it with the order of operations, and this evaluates correctly. You got the right answer. So that's a good way to check your things, your math. So let me move this back out of the way. And there's a problem that went around Facebook for quite some time.
Oh, not these.
Yeah, there's 2 variations of it. I'm going to do one of the variants because it's really simple. And that way, whenever you run into people that think they've got the right answer, this is going to why they're wrong. Now, they're not 100% wrong. Well, before I show you the problem, the reason why they solve for a different answer is because of some ambiguity with convention. If you're in a class and they tell you to use a different convention other than the order of operations you're seeing here, you do it that way. So if you're in a class that tells you to give what's called higher priority to implicit multiplication over explicit multiplication, then you do it that way. And there are courses that do it that way. So in that case, they'd be right. However, if no other information is given, right, you have to assume that you're just using standard order of operations. That's why they call it the standard order of operations. And it's also due to what's called Markiness, which is basically you go by the convention which you're using unless it's stated otherwise. Okay, so here's the problem. 6 divided by 2, 1 plus 2. Okay, and let me make some lines here real quick.
Now this is what we call an equation.
This is an equation. This is not an expression because it has an equal sign.
Okay.
So how would you go about solving this one there?
I'll do it.
Yep.
Okay, so it's 1 plus 2, 3.
Okay, let's check that out. You did the parenthetical group first. Sounds
right.
good.
And then you have to go from left to right. See, this is where I was confused. I was always told to do BEDMAS. So in this case, yes, it would be divide then multiply.
Okay, so I do the division.
Okay. So yes, and you would, but you're right. You go left to right. So if it was the other way, you would multiply then divide. But we're going to divide first. So 6 divided by 2 is 3, and then 3 multiplied by 3 is 9.
There you go. Okay, so it's 9.
However, if you do it wrong, you get 0 because you're multiplying the 2 by the 3 to get a 6. Then dividing 6 by 6. Oh, sorry, you get a 1.
Right.
Yeah.
Yeah, you get a 1. Now, again, if you're in a class where they tell you to give this right here, this multiplication, because it's implied here. There's no symbol there. There's no multiplication symbol. It's an implied symbol. If they tell you that has a higher priority, and there's reasons to do that, it's not a bad convention. It's especially easier to put into a calculator using the implicit rule that it's higher order of operations. But for elementary math, when you're learning math in grade school and your kids are learning it, this is how they learn it. Okay, they're not learning the exemptions; they're learning the basics. So people that are higher math, stop telling kids that they're wrong when they tell you the answer is 9, because that's the answer they're expected on a test to get. And I've done this with my daughter, so I know that this is actually what they've learned. Okay, so some people say, well, how about if you use distribution? Okay, well, let's try distribution. If you guys remember, distribution is distributing something over something. In this case, I'm distributing.
So wait, what was the correct answer then?
9.
Okay.
That goes back to that slash being a line in a fraction, and whether it's all over the 6 over the 2, like how you would actually draw that versus how it's typed.
Yeah, if it was
it's a typesetting convention.
Yeah, the thing is, I can also imagine this formula being done a little differently here. You haven't gotten to it yet where you use the solid line with items above it and below it.
Right, that's
division.
I'll show you that convention at the end. Okay, so let's use multiplication over distribution, multiplication over addition. If anybody wants the link is at the Great Debate Community. I've posted it there. Just go get it and come on in, or you can ask Pseudo for it.
I don't have it.
Wait, you have it at the top, the URL.
Oh,
yeah.
Where am I putting it?
If somebody messaged you for it.
Oh, so you want me to open the message then? The messenger then?
It's Lookapeig.
Yeah, Lookapeig. Yeah, just go to G+, the Great Debate Community in G+. It's there. Yeah. It's all the links to these hangouts are always posted in the G+ community. All right. So distribution here is multiplication over addition. So let's do the before we can do the distribution, we've got to still go by order of operations. You cannot distribute this to what people want to do is they want to go 2 times 1 is 2 plus 2 times 2 is 2 times 1 is 2 plus 2 times 2 is 4, and now you get 6. 6 times 6 is 1. That's not how you do this, because if you remember, multiplication and division are done left to right in the order they appear. So I cannot do this multiplication before I take care of this division. So I have to do this division first, so I end up at 3. Now I can do distribution. 3 times 1 is 3. 3 times 2 is 6. 6 plus 3 is 9. X equals 9. So even with distribution, you get the right answer. So if you're distributing the 2 first, you're going out of order of operations because you're doing a multiplication operation before the distribution, and they are done always left to right. And believe me, you'll see videos on YouTube with people saying this is wrong. They're wrong. This is how you do it. I mean, I have numerous people, friends of mine, that PhDs in maths. Not a single one has ever said it solves for 1 using standard order of operations. It's
because 6 over 2 is 1 term in that case.
Okay, yes. I see what you've done here. Yeah. Now right, so you multiply the 3 by the 1, the 3 by the 2, and that gives you the 3 plus 6 again. Okay.
I said prove this by the Taylor series. Yeah, no. Okay. Brian said though he may want to do the Taylor series with the cosine X, which would be kind of cool. It's a little bit harder. It's not impossible. It's actually a cool Taylor series. Eventually, I might do a presentation on Taylor series of how to do a Taylor series like cosine X. It's pretty interesting. But anyways, let's get back to this. So what you're saying is this, Pseudo. You're saying 6 over. Let me scroll down here. 6 over 2, right?
Yeah.
1 plus 2 equals X. This is how you're saying, right?
But it would depend then, and then the ambiguity goes away if you're wanting to multiply the 1 plus 2 by 2 or by 6 or by the 6 over 2.
Right. This right here,
and then that would shift above and below the line or be written as you have it there.
Right. This right here is the coefficient to this parenthetical group, right? Okay, this right here, this line, the solidus, means to divide.
Yeah.
This line is actually a little bit different meaning.
Okay.
This is called a fraction bar or a vinculum.
Yeah.
And it just basically means everything on the top divided by everything on the bottom. But in this particular case, they happen to come up with the same results.
Yeah. In here it happens to be a 6 over 2, but it could be 1 plus 2 over 2.
Yeah. This right here is called inline notation.
Right.
This is what you would more likely see on a more formal thing because there is no ambiguity with this. Mm-hmm. Nobody could read this incorrectly. Nobody can say what convention you're using. It tells you I am having a coefficient of 6 over 2, which is 3, and then you go from there. Okay, so this is the correct way to write it, which is not ambiguous. This is slightly ambiguous when somebody says, "Hey, that's an ambiguous inline notation." They're correct. However, that does not mean it's not solvable. Just because something is ambiguous doesn't mean you can't solve it. Okay? Because you still go by standard order of operations. That makes sense?
Yep.
And there was one more thing about the vinculum. When people ask about the vinculum, a vinculum is also what you see over a radical, like for the square root of 4, right? Square root of 4, which is 2, right? 2 times 2 is 4. That line that goes over the 4. I don't know if I can actually. Let me see. I'm not sure how to do it in this program here, but let me see if I can. Square root 4. No, just a square. So if you guys know what a radical looks like,
the little check mark line.
Yeah, you have a check mark, and then you have a bar that goes across.
Yeah.
Right. That bar that's over the top of those numbers, that is what you're taking the square root of. That is called the vinculum as well. Okay, because it means everything under that bar. Okay. So anyways, this has been a crash course on order operations. Real simple. We're easy. If you can go back over these and answer these questions correct, then everything's going to be easy from there on out, because at least you understand how the order of operations are done for future things where we start getting into other forms of mathematics where you still have to have these basics. So with that, any other questions before I end this? Because like I said, it's going to be real short. And then I am working on another presentation. I also got the Sunday show today. So, and that's going to be probably around 11 or noon, maybe a little later. We'll see. So
Steve, what spurred you to do a show, like a little hangout about basic math?
Because Midnight Sparkle actually wanted it. He wanted to review some of the basics. I take requests if it's something that I can do. The things I won't really get into much are trig. I could if I really had to, but trig sucks. I might. There's one I might actually do on trig because I find it interesting, but I'll leave that for other people. But something simple like this, which again we've all had in elementary school, well, you forget, right? But you'll find a lot of adults that don't remember how to do order operations. Ask people, ask somebody how to solve the 3 problems I gave you. An average person, they're probably not going to get it right. I'd say half probably won't get it right, if not more. Just my experience. All right. So if you got requests, let me know. Just send,
Now, is that because they're just not good at math, or they've forgotten the math since they've learned it?
It's 2 things. One, it's not so much not good at math, but they probably have forgotten it because they don't use it. And then they say they learned it incorrectly. Like you say, oh, well, I learned that you do multiplication first. Well, you really didn't, unless your teacher was really bad.
No, it's because we were told to do the BEDMAS system, which would be division, then multiplication, then add, subtraction.
No, that's what I'm saying.
Yeah.
You misunderstood what they're telling you.
Yeah.
The BIDMOS system, when you go back to, let me show you guys here.
Yeah, with the brackets around the division and multiplication and addition and subtraction.
They share
the way you wrote it with the brackets would imply that those are grouped and you can switch them around. When you don't write them with the brackets, then it was implying that you go through these orders.
But let me show you something. The PEMDAS, BIDMOS, BODMOS, BEDMOS, PPMDAS, these are all exactly the same thing.
But what I'm saying is, when you write it with the brackets around the MD and the AS, you're grouping those together. When you write it without the brackets,
because they have equal weight,
the acronym would imply that you're going in that order.
Right, but the acronym is, you cannot memorize the acronym like that. Yeah. If you even in BEDMOS, it is still parentheses DM parentheses AS. Okay, I mean, if you really want to look at it that way, what you should think about is this.
What happened? Okay.
That's the way the math program works. You should look at it this way. BEDMOS is actually this. I could write this differently. I could write this if I wanted to. It's harder to memorize, but I could write it just as easy as this and be spot on correct.
Yeah.
It's just hard to pronounce.
I know.
Right?
I know.
Okay. All right. So I just wanted to clarify that's don't get so weighted up on the.
No, but that's what I'm saying is by putting those brackets in there. I'm saying the way you wrote it with the brackets. That would imply that these things are in a grouping and they can have a different order. Without the brackets, you are then following the acronym by the letter.
And you'd be wrong.
And that's what people did, though.
Right. And that's why you'd be wrong. That's why the brackets don't change anything by adding it in this particular case. It just clarifies what people mean when they say BEDMOS. So don't focus so much on the acronym itself, because people say, oh, look at BEDMOS says you do division first. No, it doesn't. BEDMOS says you do brackets, exponents, then you do division and multiplication in the order they appear left to right, and then you do addition and subtraction in the order they appear left to right. So don't get, like I said, don't get focused on the acronyms there. All right. Sanders says, I thought it was on my post on the community where I got multiple answers. I didn't see. Well, Sanders, what post did you post in the GDC that you got multiple answers on? And welcome, Blue. Did you learn something, Blue? Yes, awesome. So like I said, I'm going to do the Sunday show, and then I am working on another presentation. symbology and one on linear linear sets of linear equations. It's not that hard. Linear equations are actually pretty easy, but a lot of people forget how to do them. I'm going to be showing you how to do single set, and double and triple, and not that confusing. So, the banana clock and line problem. I don't remember what he's talking about in the live feed. But anyways, I'm going to end this. I have the Sunday show coming up here, like I said. So please join us for that. I hope you guys got something out of this, and thanks for watching.